So here's the video for 15-3, which is absolute value functions. I'm sorry, the previous video got cut off. The battery died on the video camera that I'm using. So I already had the flip chart filled out, so we'll go a little bit quicker. So anyway, absolute value functions. So if we graph the function y equals the absolute value of x. Again, remember absolute value, you have to go to your catalog and choose ABS. So you would do y equals, and your y equals ABS parentheses, and then type in x, and then close your parentheses so that you get the absolute value of x. But you'll see ABX. When you graph the absolute value of x, it looks like this. That's going to be our base function that we're using. So it has a min, because this is the bottom value. It's either have a min or a max that has a min. The y-intercept is where it crosses the y-axis. It crosses the y-axis right here at 0, 0. The x-intercept is where it crosses the x-axis. It lays right on that x-axis, so that is also 0, 0. Your domain value are your x values. It goes forever in each direction, so it's all real x. The range are your y values. Our y values are everything from 0 on up, so that is y is greater than or equal to 0. If you have to graph any of these, again, hit second and table once you type it in, and you'll get points along the way to draw your graphs. So looking at our same one, y equals the absolute value of x, the first thing that we're going to do is a translation. Adding a number or subtracting a number to the entire function slides the graph up and slides the graph down. So notice we have y equals the absolute value of x here. If we add 2 to the entire function, notice that our graph went up by 2. If we subtract 3 from the entire function, our graph went down by 3. Notice our min here and our min here. It went up by 2 from the original, which was at 0, 0. It went down by 3, so our min is at 0, negative 3. So this one has a min, this one has a min, because it has those 2 bottom points. This one is a translation up 2, because everything moved up 2. By adding 2 to the entire function. This one is a translation of down 3. Our y-intercept is 0, 2. Our y-intercept is 0, negative 3. Our x-intercepts, this doesn't have one because it doesn't touch that x-axis. Our our x-intercept here is negative 3, 0, and 3, 0. These 2 points where it crosses the x-axis. Our domain, again, it goes forever in each direction, side to side, so that's all real x for both. Our range here, everything that's bigger than 2, so y is greater than or equal to 2. Here it's y is greater than or equal to negative 3, because that's our bottom value. So adding a number to the entire function moves it up or down. If we add a number or subtract a number to just the x value, notice that we're adding 2 just to the x value, subtracting 3 just from the x value. If we add something, it goes to the left. If we subtract something, it goes to the right. Notice that we're going left 2. Notice that we're going right 3. So again, this was just our original one that we did at the first slide. Both of them have a min because they have that bottom value. This one's translated left 2. This one's translated right 3. Our y-intercept 0, 2 is where it crosses the y-axis here. 0, 3 is where it crosses the y-axis here. Our x-intercepts where it crosses the x-axis is negative 2, 0, and 3, 0. They go in forever in both directions, so that's all real x. And then the domain is everything that's bigger than 0 on both of them. So y is greater than or equal to 0. Reflection. So we have to think about our original one here, taking our original one and reflecting it. It's going to be that negative sign out in front. That negative sign makes this upside down. I drew the 2 original ones there. Notice that it's reflected, reflected. Here would be the original one from this one. Notice that it's being reflected. So that negative side out in front makes a reflection over the x-axis. Our y-intercept, we're looking at this bottom graph, is 0, 0. Our x-axis is 0, or x-intercept is 0, 0. Goes forever in both directions, so all real x, and it's everything that's less than or equal to 0, because it's everything down below. On these two, we're doing a combination of things. We're not only doing a reflection, but we're also sliding it left or right or up or down. So it's that reflection, but it's also going over to the right. So it's a reflection over the x-axis and a translation of 3 to the right. So the y-intercept, where it crosses the y-axis, is right here, 0, negative 3. Our x-intercept is right here at 3, 0. All real x going both ways, and it's everything less than or equal to 0 is your domain. Here we're doing a reflection, but then we're sliding it up 2. So it's a reflection over the x-axis and translation up 2. Y-intercept is 0, 2. X-intercept 2, 0, and negative 2, 0. All real x because it goes forever in both directions, and it's everything for the domain that's less than 2. A dilation makes it skinnier or wider, or you might say narrower instead of skinnier. So here's our original one again. If we multiply it by 4, a number that's bigger than 1, it's going to get skinnier or narrower. If we multiply it by a fraction out in front, it's going to get wider. So both of them have mins. We have a skinnier one and a wider one. That's the dilation. All right, it's a dilation that is skinnier, a dilation that is wider. Y-intercepts are 0, 0s. X-intercepts 0, 0, 0, 0. All real x because it goes on forever in both directions, and both of them go up from 0, so y is greater than or equal to 0. So that's it. Go ahead and try the homework for 15.3.